Right.
Oh, well, thanks for joining us, everyone. We're back here, and we have some goodies here on the table with us.
Indeed.
So before we get into the
Sure.
goodies, let's find out a little bit more about perception robotics. So what specific development are you working on currently?
Right. So Perception Robotics is a startup company that focuses on advanced technologies inspired by nature. So we try to take the lessons learned from biology and apply those to robotic problems.
Mathematics, biology, it's all tied in together.
Yeah, exactly. It's a lot of polymer chemistry, a lot of electrical engineering. So yeah, our two technologies. One is a robotic pressure sensitive skin. Here, this is actually 3D printed, so it's pretty cool.
What?
So this can
3D
discern
skin? So then
3D
you'd
printed
actually
skin.
Okay, what would this be used for then?
So one of the human behaviors when you or I go
Look
to
at this, guys.
so when you or I go to grasp something, our eyeballs say, "Hey, I'm going to go grasp this microphone," but our hands are expecting feedback and a certain feedback that allows us to execute that manipulation task. So those types of behaviors are completely absent from robots right now. So what we're doing is we're providing the eyeballs for the robot to say, "Hey, I'm going to go grab this," but also the feedback on the skin surface that say, "Hey, I grabbed the object I wanted to, or I didn't," and then once they do grab it, tell how hard they're grabbing. So in the case the object's fragile, like an egg or a ceramic device, you wouldn't want to break that. So yeah, we're trying to make robots a little bit more like people. We focus on industrial robots, creepy
The
Terminators.
robot squeezes and breaks the egg, whatever, because it doesn't know how hard it's squeezing. But now you have the start to robots being able to determine how thick, how soft they're touching things or how hard they're touching things. So this is fantastic.
Yeah, I got my start in prosthetics, so that was some low-hanging fruit. And then, so that deals with things that you can physically wrap your human or robot hands around. If you're going to grab something really big, the only way is to really stick to it. So we are also working on a gecko gripper. So one of this guy's brothers just came back from the space station. So I used to work up at JPL. So shout out to Aaron Parness's group.
Shout out.
So yeah, so the idea is, if you were going to stick to something like a big glass panel, or in this case, acrylic panel on Earth, you might use a suction gripper. But if you are NASA and you are in outer space, you can't use a vacuum gripper at all, so you have to look for something else. But the idea
There's
is
no vacuum in space.
Exactly. So
you don't even think about that.
So you can't draw suction on anything. So this guy has little itty bitty micro to nanoscale hair structures on it. You can't see them because they're too small. But right now there's very little contact area between the device. But if I go ahead and actuate the gripper, press down, these little hairs flop over, dig into the surface. Intermolecular forces called van der Waals take over, and it becomes very sticky. So
wow.
So yeah, and I don't know if you've seen a gecko run up a wall. They do it very fast. So that's another advantage of this type of technology, is they can become very sticky or not sticky really, really fast.
Did
really,
you just
really
give
quickly.
a clue on what you're going to be working on?
Robots
that can run up the side of buildings? That's
I can neither confirm nor deny that statement. So.
Well, if you're already working on robot skin, who knows what you're working on next?
Right.
Well, so tell us, what are your goals with perception robotics? We see where you've started, but what is the big picture for you?
Right. So if you go into an automotive plant or most any other facility, you're going to see robots behind fences. They're not interacting with the people at all. There's the people space, and then there's the robot space. And another company that we're working with, Universal Robots, is kind of breaking that barrier. So it's more robots working alongside humans. So there's a couple of things. There's a lot of enabling tasks which allow collaborative human-robot interaction, but there's also a lot of just savings in space. So now you don't have to pay for this fencing. You don't have to pay for all this extra standoff space with the robot. You can have environments more collaborative and together. And another thing that I think that necessarily implies is people are really good at making messes and not cleaning them up. So if a robot is interacting with a person, robot will set an object down in the exact same spot over and over again with very sub-millimeter precision. A person is not going to do that. So it implies that the robot is going to need some sort of sensing system to be able to cope with the unstructured uncertainty that comes along with people. So if there's ever going to be robots in the home, toddlers and kids and things and pets and people will be disrupting the environment, and the robots are going to need to be able to have a sense of vision and touch to be able to interact with that object in a meaningful manner, or the environment.
Yeah, you said the key word, which is reliability and trust. So when you think, like, most people think, like, oh, we're bringing in robots now into the workspace. Now they're thinking, oh, well, they feel like maybe there's less reliability. But no, you give a robot a storyline. We were just talking about this with Robert. You give them an interactive storyline. Put this item here repeatedly. It's going to do that until, unless there's a power outage.
Yeah.
And you might have some malfunction, like that happens with any toy or any robot. I mean, you have to fix things if it, the longer that they get used. But you can rely on them.
Yeah, and I think you bring up a great point. Our company is focused on industrial automation, but I mean, if you imagine robots in 50 years, they're probably going to be in the home, and they're probably going to have.
They are already. I mean,
exactly. Roombas and whatnot. So by
there's Roombas, yes, there's Roombas, but there's also these like 2-foot tall. They were featured at the AI for Good show at the Center for Creative Consciousness, and I'm spacing on his name right now, but it's they've sold 20,000 units of this home interactive robot that dances. It's touch screen. Its head is touch screen, and you can ask. You can educate yourself. It specializes in special education. So there are things that are already in the home, but on a very small scale because they wanted to make it look friendly.
Yeah, exactly.
Whereas in the future, we will have human-sized robots in the home. I mean, the movies determine everything, right?
Well, it's other industries determine everything. I think it's how did Blu-ray win over HD or Betamax over VHS? Adult film industry. So here in industrial robots, I think that the advances that we're making there will percolate into the home. It's the same reason we all have computers in our pockets. It's NASA and the Air Force throwing a lot of money at making computing very small so they can miniaturize those things for outer space and aerospace usage.
And there's obviously more leeway now in the thought of having robots in your home, especially when you're building technology like this. I mean, you're creating something that hasn't been done before, and that could be one of the things holding that back. So now you're creating that opportunity. So I'm so happy that you're doing this. And lastly, see, there's like so many different questions I want to ask you, but so little time. So what specifically caused you to start working with robots?
So that's a great question. So I actually got my PhD working on sensors for prosthetic hands, and fortunate for the world, but hard for a company. There's not a lot of upper limb amputees, so we were looking for other application areas. Like, okay, maybe we have this great fingertip that can sense all the same stuff that a human digit can. So now how do we take that and move into other areas? And naturally that kind of blended into, all right, looking into industrial automation, looking into space robots in the instance of the Gecko Gripper. So that's really how that happened. And from a frustration standpoint, the human biology kind of functions as a bottleneck for a lot of things when you're trying to relay a rich data set of information from a sensor back to the person. It's having just the sensor is like having one fax machine. You can send the data out, but with nothing to catch that and display that to the person in a meaningful manner, it's kind of useless. So with a robot, it's a little easier to communicate because it's one computer talking to another. So that's naturally how my career has kind of evolved. But there's always been a fascination with how do we take lessons learned? Why is a toddler so good at stacking blocks, but a robot is so bad at it? That seems kind of messed up. So there's a lot of those challenges that I wanted to.
Seems a little messed up. Come on, robots! Come on, robots! You can do it.
Sad sack of robots can't stack blocks. So, anyhow, I hope that answered your question.
Oh no, you did. That shows us exactly how you got involved, and you said you're involved with the industrial side of robotics,
right?
And so
that's true.
You can attest that there are now more jobs in technology providing industrial robots than the jobs that got taken away by them, correct?
Yeah, exactly. Yeah. They're a force multiplier. Now, also I like to refer to the 3 Ds of robots. If it's dumb, dirty, or dangerous, you should look at having a robot do it as opposed to a person. I think that people should be artists and engineers, not necessarily sweeping the floor. I think that's something that, I don't want that job, so a robot can have that job.
Let's expand everyone's minds.
Well,
I mean,
exactly.
now we've got robots to do the things that we've been doing for eons.
Yeah, exactly. The value add of a person is your brain and ability to be creative. So let's let robots enable that. Not to mention that you're creating jobs by having who's got to build the robot, who's got to fix the robot, who's got to program the robot.
Right.
So.
Well, thank you so much, Nicholas. I'm so happy to have you, and we've got so many more people coming for you, so stay tuned. We'll be back in seconds.